We are live for another Backstage Pass session, special Halloween edition. So apologize for not being able to see my face. It's kind of convenient. It's a little easier to talk on screen when I know nobody can see me. So I'm hiding behind the mask. Have some colleagues here with me, Paul, Marc, and Jacob, all ready to do some wicked demos for you. Talk a little bit through HashiCorp, the HashiCorp stack, and the things that HashiCorp is doing, as well as a special sort of surprise demo at the end of this. So like all of our Backstage Pass events, and I'll just kind of chat a little bit while we kind of wait for folks to join the stream. Like all of our Backstage Pass events, the intent for this is to be interactive, and feel free to drop a comment in the comment stream here, and we'll pick it up and answer questions and answers, all that sort of stuff. We'll do a special Q&A round at the end for anything that's kind of left unanswered. Other than that, sit back and enjoy the presentation. We'll keep the presentation content as light as humanly possible, and really focus this isn't on the demos and all the technical pieces that everybody is here for. So without further ado, we'll get started just with sort of the intro stuff, and then I'll kick off our first presenter. So, HashiCorp stack and happy Halloween. So I'm going to run through a little bit about what we're going to do and what to be prepared for here. So I'm your host, Tim Fairweather, and here to kind of talk through some of the initial parts of what the HashiCorp stack really means, and who Arctiq is, that sort of stuff, and then go into the technical presentations and demos, real-time Q&A, as well as the wrap-up Q&A. So we're kind of chatting about, feel free to interrupt, throw a comment in the comment stream, and we will answer as we can. And we are live on YouTube, so bear with us. Live is always fun, and remote is always fun. So hopefully internet connections hold up and video holds up and all that good stuff. And it wouldn't be a YouTube event here if we didn't say please like and subscribe and all that good stuff that the kids are saying nowadays on their YouTube channels. So let's kind of continue on here. So maybe just a quick introduction from an Arctiq standpoint. If folks don't know who we are a consultancy, a services focused firm, and one of our strongest partners here is the HashiCorp. And what we're going to talk through today is some components of the HashiCorp stack, and this is part of the suite of tools and what I'll do is kind of run through a little bit of an intro on what each of these tools does, and then we're going to run through some demos. So Paul here is going to demonstrate some stuff in Vault, including replication and some rate limiting pieces. Then Marc is going to kick in and demonstrate some things around Terraform Cloud and Monorepos and Terraform Cloud in particular. And then Jacob's going to finish it off with a Consul demonstration, so multi-WAN Federation, and as well, I believe he's got a special demo cooked up. So I'll leave that one as a bit of a surprise. So to walk through what each of these tools kind of does and where they fit in the HashiCorp stack is Terraform is the starting point. All things kind of start at Terraform. Really, this is about orchestrating to clouds, multi-clouds, including on-prem. And so the idea here is to codify what you're building, codify what you're managing, keep things in line from a compliance and management standpoint, and really offer this sort of self-serve concept. So allowing teams to provision their own infrastructure, but doing it through code. And then we go into the secure piece, which is where Paul's going to kick in with a demo around Vault. And what Vault is really a programmatic API-based security and secrets management solution. So the idea is to kind of give access to the right components that teams need and applications need without necessarily exposing sensitive data and secrets. And then Consul, from the connected networking standpoint, this is really around the network piece. So this is, service registry, service discovery, the ability to put things like health checks in place and keep applications online and keep microservices talking to other microservices. And essentially, Jacob's going to demonstrate this idea of stretching this across multiple sites. And then we have Nomad, and this is really the runtime piece. So the ability to run workloads anywhere, do this in an orchestrated way, and do this in a codified way across any platform, really. So, kind of keeping this idea of keeping things agnostic and simple, really kind of rounding out the rest of this, the HashiCorp stack. And so, again, if there's any questions about any of these particular tools, these are the ones we're going to run through with the demos and really focus in on these first three from a demonstration standpoint. And like I said, happy to answer any questions along the way. In terms of our presenters, we have Paul presenting Vault replication and rate limiting. And then we have Marc is going to kick in second and do Terraform Cloud, workspaces, and monorepos. So this is that self-service cloud provisioning tool that I was mentioning earlier. And then Jacob's going to kick in with Consul multi-cluster WAN federation, and he put his secret title in here, but so it's not so much a secret anymore. He's going to demonstrate a recent announcement with HashiCorp, which is their boundary tool. So maybe a first glance for some, and kind of early insight into what the boundary tool is going to do and the things that it can offer. So without further ado, I'm going to kick this over to Paul, and then we'll start getting some demo action happening. All right, Paul, I'm going to switch the screen over to yours.
Okay. Did everybody see that? Okay. Yeah, I'm just going to talk about some Vault replication and rate limiting, as Tim just said. And let's get into it. So I'm Paul Fischer. I'm dressed up as an Arctiq consultant here. I'm not as so lame that I couldn't get a costume together, but there you go. So my focus here at Arctiq is around clouds, containers, Kubernetes, and Linux. I guess you could probably say I'm one of those crusty old sysadmins that's been playing with Linux for as long as I can remember, and that's basically me. So let's talk about Vault replication. So the replication within Vault comes in basically two flavors. One is a performance replication, and the other one is mainly for disaster recovery. So these are the different kind of capabilities of each. In my demo, I set up both, so we can kind of we'll walk through kind of both of these things. So excuse me, the main difference between these is that our performance cluster, it's available, both sides are available for write requests and read requests. So they basically act as an active Vault system that you could spread across two data centers, two different areas. And the DR is mainly a sort of like a read-only that just backs up basically everything from your primary cluster. And then if your primary cluster goes down, there's a way of promoting it into your primary. And same performance, really, you can fail over. But the key difference with the performance one is that it doesn't copy over the secrets or tokens and leases for your applications. So that is basically that. And the other thing I'm going to go over is sort of the resource quota around Vault. So Vault can limit the amount of requests that come into an API, and this is kind of useful if you want to control the amount of load that is coming onto your Vault servers, so that they don't get DDoSed or something like that. The lease count quotas it is basically holding the leases for or adding a quota around the leases for the storage and stability of it. And it's Vault Enterprise only. So.
Yeah, and I have to say the rate limiting pieces, Paul, have been a commonly asked for feature for a while as well. So it's a welcome sort of add to this in terms of the DDoS, and I'm going to expose my Vault in terms of making it available to lots of teams, or potentially even on a public IP. This stuff becomes really important.
Yep, absolutely. So this is kind of the architecture of the demo. I've got two GKE clusters across two different regions. I've got one in US East 1 and one in North America Northeast. I've got the primary cluster in the US region, and the secondary cluster and the DR cluster in the Northeast region. And I utilized just the DNS services within GCP. So you can see that we've got like Vault primary Arctiq.backstage.tk, and then the Vault secondary, and the DR one has one as well. But we won't actually really be we won't be serving traffic from that user traffic. So that is that, and we'll get into kind of the demo here. So first of all, is the font big enough here? I would think, hopefully. I'm gonna get that out of the way.
I think it looks pretty good.
Okay, cool. So so this is the primary Vault server. As you can see here, it's got both. This primary Vault is replicating to the performance cluster and to the into the DR cluster, which are on the other side. So if you so right now, where am I here? Oops. So this is the primary.
Do you want to maybe bump the font size up just a little bit, Paul?
Sure.
Just get a bit of. Yeah.
I'm gonna play with my windows here. Hold on. That a little better?
Yeah, that should be better.
Okay. So there's my primary Vault cluster, and this guy will switch as well. This is the performance cluster, and I've got the DR cluster into another namespace. So if you look back here, basically everything on here is replicating back and forth, and they're all the same. So right now there's a secret in the KV, in this secrets engine, and you can look at and test. I'm gonna do some rate limiting later on for the test engine. So what I should show you, the cool thing about the primary is that the cool thing about the performance cluster is that you can actually write to either side of it. So right now, if we check this guy, so right now I'm connected to the Vault primary. So first thing you need to do here is log in.
Yeah, and just while you're logging in there, Paul, one of the things that kind of comes up when we talk about architecture with Vault, especially in production sort of scenarios, is this idea of putting Vault in critical path for application workloads. And essentially, if it becomes the the single source of secrets for the environment, protecting this becomes a pretty critical exercise in a production deployment. Really, where the replication pieces come into play.
Yep. So what we'll do is I'm going to add a secret into that secrets engine. Great. So, and this was the primary. This is the one I added it to. So there's the secret there. And without doing anything, it's basically replicated across to the other cluster on the other side. So, and then to prove that this kind of works the other way, we can go down here to show you that I'm not on the same. Oops, what am I doing? This guy's on the secondary cluster. We'll have to log in AM as well. One thing I should say about the login token. So one thing that actually happens when you set up a primary and a secondary in performance is that even though it doesn't copy over applications, clusters or tokens and things, it does copy over the root token. So the root token gets actually overwritten when that happens, and all your data gets overwritten when it goes to the performance cluster. So one thing that you should do after that sort of setup, or one thing you should do before that, is set up a user that can actually access this stuff. So I set up this guy, tester, who's basically a super user, and this guy gets replicated as well right across. If you try to use the root token, which you should never do anyway, just you can regenerate that one on the performance cluster, but if you try to use the root token, that root token that you've originally set up the performance cluster on is gone. It's been deleted. So
yeah, generally the revocation of the root token is one of the first steps we want to do after we get something deployed and get an admin policy in place, that sort of stuff.
Sure. That's because I'm too lazy to type. Okay. And then what we'll do here is create another one. Go here. There, now I've just written to the secondary cluster. And here's the secondary cluster. And there's the Hulk. And if you go to the primary cluster, that should be there. It's interesting. This worked like 20 minutes ago.
Live demo magic.
Yeah. So that's interesting. So let's see what's going on here. Well, what you can do with this is check to see the replication status. And you should usually do that on the primary. This might tell me I'm not logged in. There we go. So this basically dumps out data of your replication status to see if it's in sync. So the DR cluster, which we're replicating to, from the primary to the DR cluster, the thing to sort of look at these are these access logs and making sure these numbers are the same. So in the DR cluster, they should always be the same. So as soon as you write something to the primary, it should write back to the DR. In the primary, so and the Merkle root should be exactly the same. So this guy should be the same on both clusters. And the performance side, these aren't necessarily in sync. They can be out of sync because this is basically and I would say they're out of sync. It's just that if you write, because it doesn't copy all application tokens and leases, the last wall on your performance cluster could be different than the last wall that's on the one that's on the performance side. Sorry, the one on the primary. So these ones are both the same because so they've actually replicated what I'm not sure what happened here is why I can't see that Hulk. It's very strange. I don't know if it's a browser refresh problem, which could be. Yeah, great. That's fun.
Yeah, one of the things that we could do too is talk about the use cases. Oh yeah, there we go.
Yeah, I think it's Firefox being silly. So yeah, go ahead, Tim. Do you want to?
No, I was just going to say, when we think about the replication, the performance replication side of things, some common use cases for that is when we start to get into the encryption services and, starting to light up Vault in the path for encryption as a service with, transformation engine and transit encryption. That starts to become a critical piece where you want to scale out, less of a disaster recovery scenario and more of the gaining more performance from your Vault environment.
Right. Yep. And so with the performance cluster itself, here's the same information I just dumped with that command. There's your secondary there. These are some of the things you can do with the cluster. If just for kind of an operational thing, you can disable the replication if anything ever gets really out of sync, or you want to actually break the replication. You can demote the cluster, so turn it into a secondary, and then on the primary side. On the secondary side, you can promote to primary, and you can recover or reindex the state on each cluster. So it looks very much similar to on the performance side, except that you're going to have, because as a secondary, you just have promote to cluster to primary, right? And the DR side you can't really do anything with. So it's basically very much a read-only database. It just shows you when it was last written to. And in the managed side, you basically can promote this to a primary. So if your primary fails for whatever reason, you can actually turn this right into a primary, and then it becomes like a fully operational primary when you can write to it and do all the things that you can normally do with your primary. So that was what I had on the replication side.
Yeah,
Now,
and so quite often we see from an architecture standpoint in production a combination of these two, which is a good part of kind of having these showcased here. Is normally in a production setup you'd have a combination of disaster recovery replication and performance replication to meet the needs of whatever Vault is serving for a particular use case.
right. So what I'm going to do now is this is primary. Yes, on the primary, I'm going to we're going to rate limit. So here's something that's really important, and I learned this while I was doing this. So something to be very aware of. If you, in fact, where's that command? So this is the command to actually turn on rate limiting. The really, and it's of course going off my screen. But this part of this is pretty important. So right now I'm setting it to a path, right? So I'm setting it to this engine here, right? If you do not have that path variable, it sets it globally, right? So if I did something like this, rate of 1, that means basically 1 transaction per second. Across globally, across the Vault clusters, you would be running into some serious problems, which I won't say I did. I didn't do that, by the way. So yeah, so
it never happens when you're building demos, Paul.
Yeah, exactly. So it's a really important thing to learn to do and learn. I'm sure you could set things globally, but if you are going to set them globally, you should make sure that they should be at a pretty high rate. For your cluster. If you set it too low, you're going to have all sorts of problems with just grabbing kind of anything from like sys or anything else. So let's set this to 1. So this is basically, of course, I'm logged out. That again. So I set the rate limit. That limit will, excuse me, be written to the secondary as well. And so what we'll do is I've got a little script here that will actually test this. Basically, it's going to try to create a whole bunch of credentials at a very fast rate. Some of them will go through depending on. So basically, it's limited to one transaction per second on the API. So depending on how fast my computer can do this, it'll actually like block some of them and allow others. So thinking about it. So there's one that's hit the quota, exceeded. So and the other important thing with this is that this is there. So it's created a bunch of other ones. This is wide across the clusters. So if I start doing if I start grabbing too many because the quota has been limited, it'll exit out even from the GUI, right? From the UI, because it's accessing the same API. So I mean, this is set at an extreme low level, right? Like one per second is pretty ridiculous. But yeah, the performance cluster would be the same, or the secondary would be the same as well.
Yeah, I don't think we'd see too many use cases with 1 per second. That's for sure.
No. And then the other thing is, so on the secret side, it's basically the same thing. Oh, see, I'm getting quote errors now. Oh, that's actually supposed to happen.
Yeah, I think the per path quotas is a pretty powerful thing too, because I could see this being a pretty significant use case for things like dynamic secrets. So some of the cloud secrets engines as an example, and setting rate limits on those so you don't have, things consuming too much out of your Vault infrastructure.
Right. Just going to look at the replication state again. Oh, yeah, it's fine.
I don't think Firefox is your friend today.
No, definitely not. So that was just basically rate limiting. So And as simple as that. You just need to put in where your path is, what the rate that you want the transactions per second to be, and the lease count one works exactly the same, except you're on a different path, and it would just apply to leases, tokens. And that was pretty much it for the demo, I think. Short and sweet.
Perfect. Thanks, Paul. I'm gonna bring the other guys back into the stream here. I decided to go backstage and do a little bit of a change up because I didn't want to scare everybody. Yeah, that was a very cool demo. Some of that stuff has been stuff I've heard, being requested for quite a while, just in terms of being able to rate limit, and obviously the replication side of things tends to be something that's a hot topic when we think about production workloads. I know myself that the DR one tends to be one that you can't kind of avoid, right? As soon as you start to put this in critical path, the next question is, how do we survive a disaster? So
yep,
that was awesome. Thanks, Paul.
Problem.
So next up we have Marc. Marc's going to give us a bit of a rundown on Terraform Cloud, and Monorepos. I'll let Marc kind of kick things off here, and then I'll move it into full screen here.
Great, thanks, Tim. Great demo, Paul. So yeah, I'm going to be talking a little bit about Terraform Cloud and Monorepos and kind of what that looks like. The demo kind of came from, I hear a lot of customers asking when they're working with Terraform Enterprise and Terraform Cloud, how do I manage workspaces and prevent workspace sprawl? And what does that look like for my backend? So let's just kind of dive into it. So first up, about me, I'm one of the consultants at Arctiq. I do a lot of work with infrastructure as code. It seems to be more specifically Terraform than anything. And I do a little bit with secrets management and helping people move to cloud as well. So what is Terraform Cloud? So some folks are familiar with the enterprise offering, Terraform Enterprise. There is also a SaaS offering out on the interwebs called Terraform Cloud. You can go sign up for a free account and do much of the same things as you can with Terraform Enterprise. They have different tiers, those sort of things. What it gives you is a single control plane for managing Terraform projects. It helps with team collaboration, has really good VCS integration, whether you're using GitHub, GitLab, et cetera, et cetera. And another nice thing that a lot of companies like is the private module registry. I'm going to try to touch on a few of those different pieces as I go through the demo. So monorepos. Why monorepos? What is the difference between many repos? So in a many repo scenario, it's very much like silos within an organization. You might have a single line of business having all their code in a single repository. You might have a networking team with all their code in a single repository, and there's just barriers people can't see, doesn't have the same visibility. With a monorepo, if you have a good structure, it's very quick and easy for teams to collaborate and take a look at what's going on across the project. So why would you want to do that? Well, it becomes a single source of truth. It gives you versioning for the entire platform. And I'll get into what that means exactly when we do the demo. Gives better visibility as things are changing. You can see impact across the organization or that project easier, and it does allow for much better collaboration. And I just grabbed a few companies I thought would be interesting to mention. So companies that are using monorepos today are Google, Salesforce, Twitter, and Facebook. So there's some big companies successfully using this out there in the wilds. Okay, so for the demo, I'm going to start by just walking through the structure of my demo repo. It's a publicly available one. We can probably make the link available after if you want to see how I strung things together. I kind of structured in a way that there's a global level, a country level, and then line of business level projects that get mapped to Terraform Cloud. I'll do an overview of how we set up the workspaces and how that maps back to that monorepo. Then we'll make some changes and watch that flow from a development environment to a production environment. And then we'll try to break some stuff and see what happens and see what gets reported back in Terraform Cloud and how to manage that. So anyone that's been to one of my demos before, they know I don't like slides, so I keep it short and sweet. So we'll get out of that foolishness. Okay, so on the screen now, I'm going to make that a little bigger.
I was kind of hoping for about 83 more slides.
83 more slides. Good. plenty of those around. So on this screen is my demo repo that I've created. Some things of note. So I'm even controlling my GCP projects through this repo. So it can create it. It'll create servers accounts, give the right permissions. I've got a global level entity. I just called it a VPC project. I thought that was kind of a good example of global entity. I've got some country level stuff going on. I've got a Canada section and a US section. And then I've got a couple lines of businesses that are using this as well. One for sprockets, one for widgets. And that's kind of that on the repo front. On the Terraform Cloud side. So if you haven't seen this interface before, it looks identical to the enterprise offering. Let me zoom in a bit on that too. So how I've set this up with my workspaces. I've tried to use a naming convention that's going to keep my sanity. So I have workspaces that map to my development environment, all with dev, and then some with production as well. And they all map back to that folder structure. So what I want to just show really quickly is what if we wanted to set up a new workspace? So I just happen to know that I've only set up one line of business in here. But if you recall when I was showing you in the demo repo, I had two. I had sprockets and widgets. So I'm just going to quickly show you what this means and how you kind of map that back to that specific directory. So the first thing we're going to do, come in here, we're going to say it's a VCS backed workflow. We're not going to be running this from our laptop, and we're not doing any API stuff in this. Pick your VCS provider. Pick your repo. And here's where you kind of map this back. So you have a whole pile of stuff in that repo. You don't want all that stuff being executed on this workspace. So what you have to do is you have to specify which subdirectory. Like that. Now, the other thing I want to do is in this instance, I always wanted to run on that directory. What these trigger options mean are whenever there's a pull request on that repo, this workspace will pick up on that there's been a change and run a speculative plan to see what's happening. In this case, we're only going to run it when the widgets directory changes, but maybe there was a dependency on the other line of business. So if I had it set up like this, a change in either one of these would queue a change on this workspace.
Is that an or situation or an and?
And.
It has to satisfy both? Okay.
It's on and. And then the next thing I want to do, because what I'm trying to do is I'm trying to create a bit of a pipeline where there's a development environment and a production environment. The first one I want to set up is I want to set it up to run on the development branch. So we're only going to be watching the dev branch on the repo. And that would be that. That's great. So if there's any code in here, we could actually queue it up. It would run. It would apply. Cool. Back to the program. So what I want to do next is I'm going to come back to the workspace level. Let's filter out some of the noise. And just take a look at the development workspaces I have set up. So this is a lot of this has been pre-staged. We're going to roll some stuff out and see some stuff changing. What we can do, you can see some stuff changing. I was polite with my git commits. There's no WTFs in there, even though I was thinking them. And I want to show too, because one of the key things to how this kind of plays out and allows for faster speed is creating dependencies between those workspaces in that environment. So I've named all these, like I said, they're all LHQ-dev or LHQ-prod. Rather than passing any hard-coded information in at any level, I have these workspaces set up to consume outputs of one another. So if I come back up here, and I'm going to have to show you a couple different things to try to get this point across. So the first thing that happens is I deployed the GCP project. I don't want any of these other projects to have to hard code what that GCP project is. I want them to consume the output ID from this project. So if I come back into my code, and I go into my project control, down at the bottom, you can see that I'm outputting that project ID. And then if I come back up, let's go into the global one. I have this imports file. And what I'm doing is I'm importing this remote state from that workspace. And I have it tagged with an environment variable that I've got set up here. So what that's going to do is it's going to read in that state from that workspace, so that project control workspace, and make that data available to the project. And then if I come up to where the VPC is actually being provisioned, rather than specifying any value or creating any variable, defining any variable, I'm specifically saying, go grab this output of this from this project. That's the one I want you to use. And the way that I've structured it with this environment kind of helping with the naming convention, this can flow from a development space to a production space, and it's going to work regardless. There's no changes that need to happen whatsoever on those levels.
So this way you can kind of hand pick the information that you want to borrow from other states, essentially.
Yes. Another thing that I kind of thought was kind of interesting too, sometimes developers are waiting for information from other teams. Rather than caring specifically about what the information is, I think it's better if they're thinking about where they're going to get it. For example, like we use a lot of Vault at Arctiq. So rather than wondering what the information is, I'm simply saying, pull this information from Vault or pull it from some source, as opposed to have to wait to get the information. I think it allows for a faster development process. And it's more reliable because it's always going to be coming from the same spot. And so I'll give an example of that as well. Oops, I come back into the demo org and I come into, oops, oh, I'm back too far, sorry. So if we come into, for example, the line of business one, because I'm importing more stuff here. So I'm importing information from 3 different workspaces. I'm going to pull some information from the network, pull some information about the VPC, and the actual project, and how that maps out in the compute instance is you can see that it's going to be pulling the project ID, the subnet ID. So I don't have to specify the subnet. I don't care about the IP address. I just want to make sure that it's on the right network. I don't care what it's called. I don't care what the IP address is, any of that. And another thing that is really nice about that, and it's one of my pet peeves when I'm writing Terraform, is the duplication of variable definitions. It seems sometimes that you're defining them in the root module, in the module that you're calling upon. You're just declaring variables all over the place. But by doing this, you don't need to define it because it's a data point in a state file.
I imagine this gives you a measure of consistency too, because you're able to make sure that everything's pulling that same value, and you don't have this issue of potentially forgetting to update a variable in one part of the code versus the rest.
Exactly. So if I take a look at this line of business workspace, I'll show you what I mean about the variables. I have 2 variables being specified. One is just for the environment, and the Google credentials for the Google provider. So it's nice and easy that way. So what I want to do now is we're going to actually roll out some compute to that line of business project. I just find where my VS Code window is. There we go. Is that size okay for people? I try to increase it a little bit.
Yeah, it seems okay. It looks okay from here.
Okay. So yeah, another thing that we are touching on here is I'm using a module and I'm pulling it from that private registry module I've created for my organization on Terraform Cloud. Maybe just really quickly, I'll show that because I mentioned in the beginning. So I have this organization, basically LeBlanc HQ, and I have these modules that I've made available to myself. It gives you really good consistency. I get to provision specific versions that I call upon within my code. And if you have a paid version or if you have Terraform Enterprise, you can do some control with Sentinel to make sure people are using the right versions, decommissioning the right versions accordingly. Kind of nice that way. You see the different versions. That's really all I want to spend on that. I'm not going to spend a lot of time. Let's go back to VS Code for a minute. Okay, so we're going to basically deploy this guy and request some compute on this line of business project. All right, okay, and I'm going to close that for now, and I'm going to try to give you two views. Hopefully this looks big enough when it's set up. Okay, so on the left side, I've got Terraform Enterprise. On the right side, I've got GitHub. What I'm going to do, we're going to make a pull request for that sandbox branch. What I want to do is I want to go to dev. Yeah, that's right. I want to actually come back to the workspaces. Filter that out. And the one we're going to be watching is this one right here, the Sprockets one. There's a couple things I want to show that are kind of neat with GitHub and the way that it integrates with Terraform Cloud. So right away, one of the benefits I can illustrate when you have a monorepo and Terraform Cloud. These checks that are running here are automatic webhooks that get set up. And what this is, remember when we were setting up those triggers, it said run a plan when things change in specific directories. Well, it generates what's called a speculative plan. So it doesn't actually run the plan, it doesn't actually run the apply, but it says, hey, here's the changes that are coming. Before I even merge it into that development branch, I already have an idea of what's going to happen to my infrastructure. Very, very powerful for approvers to have the information they need to know if this is ready to go. It can also be set up that if we were watching other directories, we could see what else is happening. So if, for example, if we had set that widgets one up to watch sprockets and widgets, it would have ran the speculative plan on both directories. Really handy to see what's happening within your infrastructure. So we're gonna go ahead and merge that.
Yeah, the nice thing.
Yep.
The nice thing here too, Marc, is you can set up branch protection and make those check statuses required as well. So you can kind of make sure that nothing gets merged that shouldn't get merged if it failed a speculative plan.
Exactly. So when I hit merge, we should see in a moment here, we'll see this get picked up by Terraform Cloud. We see that it's planning automatically. Just takes a moment here to plan finish. So everything looks good, green check marks, confirm and apply. And if I switch over to my GCP window, you should see it pop up as a VM over here in a moment. This is usually pretty quick, but we'll give it a minute before I move on.
It might need a refresh too in the browser for GCP. And did you have to do? You didn't have to do anything special to set up those check status in the PR or anything like that. That's in the default VCS integration with Terraform.
That is
Cloud.
out of the box functionality. I think I discovered it mostly by accident when it showed up sometime over the summer. I think it's a fantastic addition. So yeah, if I refresh that, we'll see a little VM there. There it is.
Yeah. Cool. I have to say, spending the last couple of days figuring out custom commit checks in GitHub with a pipeline, that's a welcome addition to have that built in.
Yep. So I'm going to drill back up, and now we're going to watch production, because where the real power of this comes from is the lack of change I need to do to make that exact same change replicated from dev. Okay, I'm happy. I've done my test. I've done my function test. Everything looks good. Let's roll this up to production. There are 0 code changes for this to work, as long as your workspaces are set up. And normally, I think if you're into this sort of scenario, your workspaces are being set up by a pipeline, so it's all programmatic. They should all be identical for your environment, however you want to kind of handle that. So if I come back up, we're gonna make a new pull request.
And then so you have your prod workspace tied to a different branch inside of Git.
Correct. Yeah. So when I was set up, I'll just pull one up. We're going to be working with sprockets. So if I come into my settings and I come down to my version control settings for that workspace, it's a default branch. And in this case, the default branch is master. You could specify that to be whatever. All right. So we're going to open up a pull request from dev to the master branch. Same thing, it's going to run those checks. And on this one, I do have branch protection. I didn't care about my development branch as much, but in my master branch, I do, because it's going to production. So same thing, we can open this tab. We can see that it is running in the production workspace. Same thing, everything looks happy. So I'm going to come back.
Yeah, I like that it embeds the links to go look at the logs and find out what's going on in Terraform while you're
super handy. Absolutely. I'm not sure why that's not kicking back with the green arrow, but I know it's going to. So I'm going to go ahead and override that.
It's kind of like using the root token in Vault, isn't it?
Kind of. And there we see that the workspace has picked it up. Confirm and apply. We can watch that, but while that's happening, I just want to pull the GCP window up again so we can see some things I just want to showcase. So if you recall, I had the projects being created by Terraform. So one's dev, one's prod, identical. And then if I switch to my VPC networks, we have one arc-dev corp VPC01. I have a subnet that says CASnet01. So if I switch from dev over to prod, do the same thing. Arc prod corp VPC01, CASnet01, slightly different IP range, 10.2. Oh, they're the same. I thought I changed them. And then if we switch down to the compute, let's see, this is apply finished. Let's give it a little hit here. And there it is. So we have 2 VMs, one's prod, one's dev. Our environments are in sync. So that's really the power behind Monorepos and how it can map to Terraform Enterprise. I really like the speed at which you're able to make changes, how it minimizes the changes that need to happen between environment switches. I like the visibility it gives you when you do those pull requests. I think there's a lot of cool things going on there. Just for fun, unless I'm out of time, we're going to really quickly try to break something by putting in some angry Terraform code. And it doesn't really matter what we're going to do. Let's just...
Here, I'll bring it full screen if you want to demo that, Marc.
Yeah. It doesn't really matter what it's going to do. It's going to complain about this, I promise.
So is your intent here is to catch this in that speculative plan stage?
Exactly. It'll come up and we'll see it on GitHub. We'll see how quickly an approver should see that. We don't need this window anymore. Make this big. Rather, this one. Let's do a new pull request. We're going to go to dev from sandbox. Oh, I didn't do the push. There we go.
So on push to a branch, nothing happens. It's only when you set the pull request in action. It
would depend. So I'm pushing to a sandbox somewhere. I thought that was more an actual pattern you would see. I don't think you would have developers pushing directly to a branch that's setting up some sort of an environment.
Yep, that makes sense.
So pull this up, close these other guys. Yeah, so it's going to come up and say, I have no idea what's going on here. And that should come back in a failed status here. Let's give it a refresh.
Yeah, that's very cool, especially if you got that set as like a mandatory check for
yeah, I think there's a lot of power there. There it comes up here. So right away, if you're an approver that's a change manager, maybe you're not really technical, you can really quickly go, something's going to happen, something's not right here, and reject that change.
Yeah, that's awesome.
As far as the demo, that's pretty much all I got, unless someone has questions. I guess maybe we're coming back to questions in the end.
Yeah, no, that was great. I think it showcases a really valid use case in terms of, kind of bringing this idea of full on, Git ops focused infrastructure and infrastructure as code builds.
Absolutely.
Cool. Thanks a lot, Marc. That was awesome. And so we're going to kick this over to Jacob, and we'll kind of do a wrap up Q&A round. So we have our resident Dodger, the only one. Well, I guess Paul dressed up as an Arctiq employee, so we've got a couple of costumes happening here. So let's jump right into to Jacob's section here. Jacob, I'll start to share your screen here, and you can kind of tee off what you're going to demo and everything else.
Cool. Yeah, thanks. You can hear me okay?
Yep, absolutely.
Cool. Okay. Yeah. So I'm going to do I'm doing 2 demos. Yeah. I think I accidentally put the second demo in the agenda. But that's okay. It'll still be I'll make it a surprise when I go through it. But the first demo I want to go through is Consul multi-cluster WAN federation. So this is basically kind of the concept of I'm trying to now as a customer be like multi-cloud or use like a hybrid cloud where I'm kind of on in like Azure, GCP, and also on-prem. And now I'm looking for a way to kind of join my data centers together for my applications to communicate. So this is like kind of the concept of Consul WAN federation. So I'm going to go through that first. Cool.
Awesome.
So a little bit about me. My name is Jacob Mammoliti, consultant at Arctiq. So I mostly focus on a lot of the HashiCorp tooling, so a lot of Terraform, Vault, and Consul work. And when I'm not either working on one of those three tools, I'm probably doing something with Kubernetes as well, mostly like GKE, and recently for this demo, AKS, Azure Kubernetes Service. You can find me on Twitter and GitHub with that handle. I actually have the Terraform code to deploy what I did for Consul in GKE in there. So you can look up that repo. I don't remember what it's called, but I think it's pinned. So it's like Consul GKE Terraform or something like that. I used it for a previous talk, so you can find it there for most.
Yeah, we can share out the links to the attendee list. That way everybody's got it.
Perfect. Cool. Okay. So quickly, what I do is just like level set on Consul. Tim, you talked about it earlier, kind of like what Consul is, but quickly high level, Consul is a service discovery tool that provides like a catalog of available services in your data center, we'll call it. Consul uses the term data center to kind of represent like an environment. So like my GKE cluster would have a data center. When I deploy something in Azure, that could be a second data center. So Consul provides a way to view all of my services and provide stuff like health checks to make sure that I'm able to access services, healthy services. And I don't really have to matter so much about kind of the IP address of that host. And especially as we move to a more dynamic model, everything is going to be getting new IP addresses pretty quickly, especially if you talk about Kubernetes where pods are spinning up and down. So now we want to kind of look more at like the service level. I want to represent, or I want to call on services by their name. So Consul does a good job at kind of discovering those services and giving me a catalog as to what's available and what's healthy. The other side of Consul, which kind of goes hand in hand a lot now, especially in the Kubernetes space, is Consul's service mesh feature called Connect. So Connect provides a service-to-service connection, authorization, and encryption using mutual TLS. And then the other thing that we're going to talk about here today, which is kind of new in Consul 1.8, was the idea of Consul Mesh Gateway. And I'll go through that in the next slide where I kind of show a high-level diagram of what a Consul deployment in GKE and AKS look like and how they communicate over Consul's feature called the Mesh Gateway. The other thing I want to talk about is that the demo is kind of around federation. So when we talk about federation in Consul's terms, what's really meant is the act of joining two or more Consul data centers together. So this is kind of contributing to that multi-cloud story where I have a bunch of my applications running in say GKE and AKS, like I'm going to do in this demo. But now how do I get those services to communicate with each other? And how do I get them to communicate with each other securely and kind of off that single pane of glass where I don't have to maybe log into Azure and see, okay, here's the services running. I don't have to log into in the GCP console and see here's the services running in my GKE cluster. I can use something like Consul, which would sit in both environments and kind of give me that single pane of glass to see all of my services and give me a way to flip between those data centers pretty quickly. So we'll see that when we go into the actual demo. And then, of course, with using Consul or like any other service mesh tool, you get all of the features that a service mesh brings you. So the first one I kind of talked about was the connection authorization. So I can use something what Consul calls intentions to kind of say, this service A is allowed to talk to service B, service B can't talk to service C, and so on and so forth. So it kind of gives you a way to gain some sanity as to what applications and what services are actually talking to each other. The final point too is around like layer 7 routing that you can get with Consul, and this helps with stuff like multi-cluster failover or traffic splitting as well. So here is kind of like my diagram to kind of encapsulate everything I'm going to show today. It's pretty high level, but it was kind of enough just to kind of show you what's actually going to be going on in the demo and to give you an example of what WAN federation would look like. So really the idea behind WAN federation, all it really is, it's the means of connecting two data centers together. So traditionally before Consul 1.8, one method of doing this would have potentially been exposing all of your Consul servers to, we'll say, the public internet, just so that they could communicate with another data center. So in this diagram, it wouldn't be too bad, just because we're only running 6 Consul servers. So really, you just have to have you'd have to have 6 public IPs, and plus you have to manage the firewall rules. So it's manageable. No one would really want to do it, but like you could if you absolutely had to. But as we start to scale this out, as I bring on a cluster in AWS, or I bring in an on-prem cluster, this can start to get very A, expensive to manage, and B, just like it would be a lot to work with, because if I accidentally missed a firewall rule for a new public IP or something like that, or just latency maybe between 2 separate Consul servers, it can get bad pretty quickly. So in 1.8, Consul brought in the idea of a mesh gateway. And what this is now a separate deployment that sits in each of your Consul clusters that you want to expose to other Consul data centers. And now this has a deployment, and it has a service that sits on the edge of your Kubernetes cluster, or on the edge of your data center, that would have a public IP. And now it's using Consul's WAN gossip to communicate with other data centers. So you're now able to communicate not only securely, but kind of all through like a single sort of point. So now this becomes a lot easier. When I bring up a cluster, we'll say in AWS, I now only have to deal with 1 public IP. I only now probably have to, it's a much smaller firewall rule I have to open up if I need to get these clusters to communicate with each other.
And this would work across multiple platforms outside of Kubernetes as well, right?
It does, yeah. So that's one of the things I actually like. I think Consul's done a really good job on, because the story around like containerized workloads, as well as like VMs, is really good. In that, at the end of the day, as long as your VM has a Consul client running on it, you can essentially join a Consul mesh. So the story is pretty good around that. So yeah, you don't have to be totally containerized. I could easily have my data center in on-prem that's running like VMware. But maybe I don't have any Kubernetes in there. Maybe it's literally, I have 3 VMs that are running Consul server, and then my database is running Consul client as well, for example, to be able to join the mesh and then essentially be able to connect to everything else that maybe we see in this diagram here. Quickly too, before we get into the demo. So the idea of this would be that if my app A needed to talk to app B here, so app A is sitting in GKE, app B is sitting in AKS, the flow would basically be app A would send a call out to Node to connect to app B by referencing its service name, as well as passing in the data center. From there, the Envoy sidecar proxy is able to hand that off to the mesh gateway, which would then send that through a tunnel over like the WAN gossip tunnel there to the other Consul mesh gateway, and then eventually hand that off to app B, the app B pod, which would be intercepted by the Envoy proxy as well. So with further ado, again, I'm not somebody who likes a lot of slides either. So we will just get right into the demo as well. So quickly, what I showed here, and I ran this command earlier just to make sure that both of my clusters were still running. I have a Kubernetes cluster running in Azure, so an AKS cluster, and then I have a cluster running in Google Cloud, so a GKE cluster. They're both 3 nodes. They're both 3 nodes clusters, and I already have Consul deployed on both of them. And I've set up the WAN federation as well. But what I want to do is I just want to show you what like a Consul deployment would look like with Mesh Gateway turned on in Kubernetes. So right here we have 3 Consul pods that are running like in server mode. So those Consul servers you see. And then we also have our Consul clients right here. So the other ones that are like FG, QD, and RN. Those are responsible for running on every single Kubernetes node in my cluster. Again, this is just that's able to pick up when new services come up or get scheduled in Kubernetes case on that node. And then we have our Mesh Gateway deployment. So it's just running 2 pods of it, just in case, kind of like more for redundancy purposes. And the other thing that we want to see that is important to notice here is when we do a get services, we see that external IP. And it's important because this external IP is what's going to be used and sent over to when I built my GKE cluster to say, hey, here is a Consul data center. I want you to connect to it. And we do that by, when we configure it, is sending over like a CA that Consul generates, it creates and generates. It then creates a certificate and private key for it. And it's sending that over and communicating with the GKE cluster. So that way we can kind of secure that connection even when it's going over the internet. That way, none of our actual traffic is, if it is ever intercepted, it's not, it's pretty much all like ciphertext. You can't really do anything with it. GKE looks pretty similar. So if we do some of the same sort of thing, you'll see again that we have, we'll see that we have our 3 Consul servers, 3 Consul clients, our mesh gateway again. And then again as well, this has a Consul mesh gateway service in Kubernetes. It's a load balancer type. So that way we have an external IP and that we can get traffic into our cluster. So I'm going to go ahead and clear this. And what I want to do is I want to actually get onto the Consul UI so we can kind of see what's going on here. So I'm just going to forward it because my Consul UI service doesn't have a public IP. So what we can do is I can now just copy my local host. I've port forwarded to 8500 and HTTPS. And we can now see, I'm going to make the Consul side a bit bigger. We can now see a Consul UI. So if those aren't familiar, this is what Consul looks like when you bring up the UI. You'll have all of your list of services here, which we have our Consul clients, or sorry, our Consul servers, as well as the mesh gateway. So these are just services that Consul has picked up and registered to its catalog. You can also see nodes, so all of the nodes that are acting in your Consul data center. And then Consul has other features like key value, ACLs, which I haven't enabled here, and then intentions, which I'll show shortly as well. So the big benefit, though, is the idea that, like I mentioned, with WAN federation is the ability to kind of view multiple data centers from kind of a single point, right, or a single pane of glass. So like I mentioned, I've already bridged my AKS cluster and my GKE cluster together. So the idea is that I can come here now and click a drop down and click my Azure data center. And now right away, I'm in my Azure data center. I can now see all of the services that are deployed in my AKS cluster. Obviously, there's nothing, and it's very similar to the GKE one, just because these are 2 like empty clusters right now. So again, we're going to see the Consul servers, as well as we see the mesh gateway. And when we go over to nodes is when you're going to see a bit different, just because you're now going to see like AKS node pool, as opposed to if we went to GKE, we see our GKE node pool. That's just like what Google names our nodes. So already we're seeing some pretty big benefits here with that WAN federation, where now we're able to join these data centers, right? So this becomes, like I said, a lot easier to manage when we want to expand this out to maybe when we want to deploy some applications in AWS or on-prem. And again, this could be containerized or non-containerized. It could be just like strip VMs as well. But at the end of the day, it's that single pane of glass where I can just flip through data centers here and see the services that are actually deployed in that cluster. So the other thing too is the idea of we can actually now deploy our application and kind of see what that looks like. So I'm going to go ahead and do is I'm going to cat out my deployments for GKE, and I'll run through quickly what the application is going to look like, and then we'll just deploy it. So this application is from a guy who works at HashiCorp named Cody Darkland. He gave a similar WAN Federation demo, I think, a while back, and I think he built this application for it. So I figured this would be a perfect app to use to kind of showcase this feature in Consul as well. So right, this deployment is deploying a namespace for our application, and then it's deploying a database pod. So how this application is kind of set up is that it has a database, it has a backend service, and then a front end, which is kind of responsible for talking to the backend API, and then the backend is going to talk to the database. So we're deploying our database. Everything has a connect inject annotation, so that way we're able to onboard these applications or these services to the mesh. We're then deploying our API backend service. And the main thing to kind of note here is, I'm just going to toggle this over a bit, is the idea of setting up connect service upstreams. So with Consul, you have to define all of the services that your your current service is going to talk to. So our backend service is going to be responsible for talking to the database, and it's also going to be responsible for communicating to our application front end. And the thing to kind of note here is the idea that we're not only specifying the service name and the port, but we're also specifying the data center that it lives in. If we leave that out, it's going to try to find database in its own data center, which would work for database because we're defining it here. But when it's trying to find the app front end in its own in the Google data center, it's not going to find it because it's actually going to exist in AKS. So we can go ahead and apply this. And what we should see quickly is on the right side that those services will get picked up by Consul. Okay, cool. We see them already. So we see our DB service and we see our Pi API backend service. And then we'll just give them a second to get healthy. Should be pretty quick. Pi API is already done. And DB is probably taking a second. I'll give it oh, there we go. Cool. So both of our applications or services for database and our backend are fully deployed. We're happy. I could do a kubectl get pods as well if we really just want to make sure from a Kubernetes standpoint. But Consul is doing health checks on it, so we know that it is fully running, and we can see that here with Kubernetes.
Is it using Envoy as the proxy, Jacob?
It is, yeah. It's using Envoy, yeah. It seems like that's kind of like the standard, I guess, across like the other service meshes as well. And for anyone who's ever looked at Envoy configs, it's very nice that people have extracted those for us because the Envoy configs are terrifying. Okay, so now we've deployed our application in GKE, right? So it's pretty cool. But now how do I get to that kind of multi-cloud story, right? I now want to I don't want to solely depend on maybe my GKE cluster or Google in general to make sure that nothing ever goes down. I want to be able to deploy to a second cloud as well in case something catastrophic happened. So this is where kind of that story comes in of multi-cloud and deploying to Microsoft Azure here or AWS or any other major clouds is the idea that I can now spread out my applications across different clouds. So in the event that if my GKE cluster went down, my application can still fully run in Azure, and my clients would may never notice. They may notice like a blip for like a second or so, just like maybe as it flips over, but it'd be very, very minimal, if any. And the idea is that you really didn't have to do anything as the infrastructure team or whoever's running the application. Consul and like that whole multi-cloud story can kind of help that and automatically solve that for you. So let's go ahead and look at the deployments for our AKS cluster. It's a bit simpler where we're creating another namespace. And we're deploying a pod that's going to be our front-end service. And again, the thing to note here is around the annotation is the upstream. So we're saying that this front-end is just going to communicate with our Pi API service, which is right here. And again, because we're working out of AKS now, or we're going to be deploying into there, we have to specify our data center. Or else, again, it's going to try to find our Pi API in the AKS cluster, which it won't exist. We can now, and then we have to deploy a service, which is just going to be a load balancer type service. That way we're able to get traffic to our application from outside of the cluster. So before I do it, I want to switch over now to the Azure data center. And as we can see, right, we don't see our services from Google just because they're not deployed there. So now we can apply this. We've created our namespace, pod, and service, and in a few seconds that should show up. Okay, cool. The front end is there, and we'll just give it a second again to pick up to get healthy. In the meantime, what I'll do is I'll do a kubectl get service, so that way I can have the public IP. Yes, pretty quick. I will say getting a public IP I found has been faster in Azure compared to GKE. I don't know if that's just I just got lucky this last few days, but I found that's the case. So I copy this IP. I see my front end is healthy, so I should now be able to go here and just give it a second. Well, it gave me IP, but it doesn't essentially mean it's ready, I guess, does it? Okay, we'll let that load for a sec. I'll just refresh it. sees the front end is healthy. Oh, there we go. Okay, cool. All right, so this is just an application that just shows the HashiCorp tools. Let me make this a bit bigger. And really what we're looking for is, as I scroll down, we're looking for our platform connectivity. So the reason why I really like this app to demonstrate is because of its, not only of its dependencies of other services that has to communicate with other services, there's a way to check right on the front end service. I can see that the API connectivity is there because it has a status green. I can see the database connectivity is there because it has status green, which is pretty cool. So what we essentially done here is I've deployed my application in Azure, and now it knows it needs to connect to my backend API, which is here. So now it's going over that mesh gateway and then hitting that API service, and that way we're able to connect to it. And then a little less exciting, just because they're in the same data center, API service is connecting to the database service, but that's like in the same Google data center. And that's essentially it, kind of to just deploy that, to deploy it across multiple clouds. It's pretty straightforward. What I could quickly show too is just the intention stuff, just to kind of show that I didn't put that there myself.
Yeah, I was going to say a nice thing would be to show intentions and how to segment and that sort of stuff as well.
Yeah. So what I'll show here is how to show the intention. So that way, like to show that, like I said, this isn't like static, so that my API actually is communicating with the database API. So what I can come in here is I'm in the Google data center. If I go over to intentions, I can create a new one. And then I can go to, what I'll say is that all services connecting to database. So I'll be pretty strict, because this is something that I see a lot actually, where by default, we want to say that by default, no services can talk to each other. And then it's up to me to layer on which services can. It kind of gives us that whole zero trust policy, and making sure that we're explicit when we say who wants to talk to what. So what I'll do here, I'll just say all services can't connect to database. And now we've blocked it. So if we come over here, we see our database connectivity is gone, right? Because now the Envoy sidecar proxy in front of database is blocking the communication from the API. So then I can come back here and just say, okay, Pi API is allowed to talk to database. And if we flip back over, there we go, already did it pretty quickly, that we're now able to have that connectivity. So it's pretty powerful in the ability to kind of do that as well, on top of kind of that whole multi-cloud storage. So that way, although you want to bring up your data center in AWS, maybe there's only like a couple services that actually need to talk to services in GCP. So you don't want to completely blow it open and allow dev team B to talk to dev team A services for no reason. Not that anyone would do anything malicious, but maybe. But you can kind of control that at the console level and say, I don't even want you guys to even, like, I don't even want to have to worry about it, because if I set an intention that's saying absolutely you can't talk to it, I can sleep easy at night knowing that your service won't be able to talk to the services that I don't want you to.
And that's at the console service level, right?
Yes, correct.
No more IP address.
No more IP address. Yeah, no more IP address, port rule, yeah, none of that sort of stuff, which is kind of like the nice thing that service discovery brings you, right? I no longer have to, especially when we talk about pods, right? Like, because I can't tell you the last time I looked at a pod IP address. I mean, Kubernetes comes like with its own built-in service discovery, right? But I mean, yeah, it's being able to kind of control at the service level makes life a lot easier. So that's, so that's it for my console demo. I'm gonna flip back over. I guess.
Are you gonna do your secret, not so secret demo now?
Yeah, I'll do my secret, not so secret demo now as well. I guess I can just jump right into it, right?
Yeah, go for it.
All right, cool. So, secret, not so secret demo. Where am I? Okay. Secret, not so secret demo is a demo on Boundary. So for those who watched or were participating in HashiConf, was that 2 weeks ago now? Or didn't, either way, you may have heard that they released 2 new tools. One was HashiCorp Boundary, and the other one was Waypoint. I'm going to be focusing on Boundary today. I haven't actually touched Waypoint really yet. So mostly just going to focus on Boundary today. And the idea with Boundary is that it is a tool to allow you to securely connect to machines. Think of it in easy terms into like a VPC based on like RBAC groups or based on kind of just like single sign-on and RBAC in general. So what I'll do is we'll just get right into it. So like I said, it was really kind of built just to modernize and kind of solidify a way that clients across your environment or across your organization can connect the systems over a network, and do that with, like I said, some sort of single trusted IDP or single sign-on. I think this diagram, even though it's really simple, speaks volumes of what basically the tool actually does. Is I can come now in as a verified user, whether I logged in through like AD or something like that, into Boundary. And then from there, I can use my identity to authenticate to machines, whether it be in GCP, AWS, Azure, Kubernetes, or whatever else that your organization has. And where Boundary is going with it is that the idea is that this will kind of be, this will use other tools like Vault and Consul to make the tool much more powerful. So with every new tool, I think there's one question that always gets asked is kind of, what is it trying to solve? Like, why did HashiCorp make it? So from my perspective, just given I've only worked with the tool for a couple of weeks, so learning a lot more with the tool. Basically, like every time I use it, I always find kind of a new way to new features that I kind of learned or found a better way to do something. So, but anyway, from what I've kind of gathered, I think the tool that's trying to solve is trying to remove that sort of traditional onboarding process that currently happens. So the idea where that if you now you get hired at a new company, you have to go through that onboarding process of getting your employee a machine and then getting them access to a private network, so that way they can work on your servers like remotely, right? And especially now that's bigger now more than ever. And kind of how that workflow works, like, right, is that you're getting a VPN profile, and that will essentially allow you onto the network. The second thing that usually takes place is setting up firewall rules so that your client only has access to machines that you would actually need. So that maybe if you're like a DBA or you're just like a developer, you only have access to development machines, right? If you try to like SSH or even like just ping a production server, you would just get blocked because of a firewall. The issue here with that is as they start to expand and we start moving to more of a fast-paced and fluid spin up, spin down machines, containers, or guest pods, or whatever the case may be, is those IP addresses are changing constantly. So we're going to have to start moving away from basing firewall rules off IP addresses. We kind of have to look at more higher up the stack. So this is kind of where Consul came in. When it was like, okay, we're not going to worry about IPs anymore. Let's kind of look at this as more of a service level. Boundary is kind of doing the same thing in a way where you no longer kind of want to be setting firewall rules as to saying, okay, me as Jacob, I can only access the DBA servers, and I now have a firewall rule by IP address, because as soon as one of those servers dies, we have to spin up a new one. It could be getting a new IP address, and now not only is that now as a new spin up a new server, we also now have to change my firewall rule because I won't be able to access it right away. The idea with Boundary was that I can come in here with tags and basically saying, look, when Jacob comes onboarded, any server that's tagged as DBA or any server that's tagged development, automatically give him access to it. And I think what's going to happen there is Boundary is going to leverage Consul in future releases to kind of help achieve that goal. So utilizing Boundary for machine access. And what we want to talk about here is kind of the architecture of what Boundary looks like. So quickly, the idea here is that as a user, actually first let's talk about what the servers actually look like in Boundary. So Boundary is the concept of two types of servers. There is a controller and there is a worker. I realized when I did this slide, actually, it should probably be the other way around. But the idea with a controller is that's like the brains behind Boundary. And that's really responsible for kind of, as I set my Boundary cluster up, as I start configuring stuff like users, what machines are they can connect to? That would all be kind of done on the controller side. And it's also responsible for authorizing, authenticating users, as well as serving like any API requests that we get, whether it's through like the actual REST API or through like the CLI or even like the UI. The workers kind of sit on top, and those are responsible for brokering the connection between the clients and the target hosts. So when I do a Boundary connect, which I'm going to show, what's actually happening is I'm hitting the worker, and then the worker is now going to hand me off to my target. So that's kind of like how that workflow sort of sort of works. And then here, what I have is like a boundary public IP address, or sorry, public load balancer that's sitting in front. That way I can hit the API. And then from there, when I do like a boundary connect, my worker would be responsible for taking that in and then distributing it across to the target. What I'll also talk about is I do have like some terminology that I want to go over, but I think it'd be best if maybe I just demo it. And then as I demo it, I can talk over some terminology. And plus, I just want to be mindful of some time as well.
Yeah, I think dive right in, Jacob.
Yeah, cool. Okay, so let me get rid of console, and I'm running the boundary UI. Perfect. Okay, so this is boundary on the right side. Let me go like this. So the idea of boundary is, like I said, it's a way to kind of centralized way to authenticate to machines. So when we set up boundary, the first thing that you're want to do is set up an organization. And an organization, that way I can think of it is kind of like maybe like your company level. So as Arctiq, right, we would have an organization. So I can go ahead and click that. Once you click in an organization, you then see on the left that you have stuff like users, groups, roles, and auth methods. This is controlled at that organization level. So each org could essentially have their own authentication methods. Right now in Boundary, all that's supported is just a user password. So I'd log in with user password. It doesn't have like these single sign-on integrations just yet, but I know they're working really hard to get that in there as soon as possible. But the idea is the next level after an organization is my projects. So I've already pre-created a project here called Blizzard. And the idea or the way to think about this, I think, is kind of like I would split up projects maybe based on like business units. So if I am Arctiq, we are creating a project called Blizzard, or we are creating a product called, I don't know, anything like something else. And then you split that up here because as the idea is I can now start fine-graining access control where I want maybe my Blizzard kind of operations team or my admins to come in and kind of have control maybe all of the Blizzard project. So when we come into Blizzard, we now see a few new resources here. And what we see are sessions, targets, and host catalogs. So what I'll do is I'll start from the bottom up just because it kind of makes the most sense to build out the story. So I'm going to go to host catalogs. And the way I like to think of host catalogs is I like to think of host catalogs as kind of a way to separate my clouds. So as Blizzard or as the Blizzard team, we may have resources in GCP, Azure, AWS, or on-prem. I can use host catalogs to kind of collect all of those hosts that belong in GCP. So I'll go in here and I'll do Blizzard, just call it GCP. I'll leave the description for now. So now we've created a host catalog, and this is meant to encapsulate all of my compute instances, or basically everything in GCP. All right, so that's one way, but of course I don't want to say, okay, everyone in my team has access to everything in GCP. I kind of need a better way to fine grain that. So that's where we get into something called a host set. And the idea with the host set is, okay, now that I've kind of called off my whole GCP, or I've carved off my GCP environment, how do I break this down even further? So I think one way of doing this is you could do it by stuff like environment, like dev, prod, QA. The other way you could do it is by stuff like DBAs or something like that. So again, this is usually something like this would be like a whiteboarding exercise if you're ever going to incorporate it and say what makes the most sense from our standpoint. So host set, what I'll do here, I'll just call it development, just development. And now we've created our host set. So the final thing that we have to do is we actually have to find a way to get some hosts in here, right? The whole point of Boundary is for me to be able to connect to hosts. So what I'll do is I'll go into hosts and I'll add one. And what I'm going to do here is I'm going to add a GCP instance that is sitting on my VPC network. So I'll copy that IP and I'm going to click save. So right now, a lot of this, like I said, is a very manual process in that right now, I have to set up all my hosts myself. Like I mentioned, I think the idea where the tool is going is that we can start adding things like Consul, or even just using like straight up cloud tags to say, I want all of my compute instances that are tagged as dev or DBA or prod to automatically fill out these host sets for me. So I don't actually have to go in and add all these hosts manually. Okay, so we've done that. The last thing we need to do is we need to create what's called a boundary target. And I already created that. Let me delete this actually. I'll create a new one. So I'm gonna go ahead and create a target. And the idea is a target is what users are actually going to connect to. So I'll call this my development targets. And we're just specifying some information here, basically saying that anybody who connects to a development target, it's kind of redundant actually. Your session is only allowed to be 28,800 seconds, which I don't know what it is in minutes. But I think it's pretty high. And the idea is to, with like maximum connections. So I can say that users can only, there's only one connection allowed for this target. You can bump this up, of course, or you can set it to -1 to have infinity. Because we want to connect to the machine over SSH, we just do default port is 22. And then we need to add our host sets. So we're going to go add here. These are development host sets. And now we've added that to our target. So now it's actually time to connect to a host in Boundary. So what I'm going to go ahead and do is I'm going to export this. The nice thing that made my life a lot easier when learning Boundary was that it's very similar to the other HashiCorp tooling in terms of CLI, which made life a lot easier to learn. Okay, so I've authenticated. Now what I need to do is I want to actually look at all of the, I want to be able to get all of the targets because I need to grab some IDs here. So I have my target ID that I'll need. I'm also going to need my host catalog that I've created. And finally, what I'm going to need is the actual host ID because I need to target a specific host. Okay, there we go. So now what I can do is I can do a boundary connect SSH target ID. Grab my target up here. And then do a host ID, and then grab this. So now what essentially this is going to do, this is now going to utilize Boundary to kind of broker the connection between myself and my target, which is that GCP instance sitting on a VPC network in my GCP project. So that target doesn't have a public IP address. It's Boundary that is sitting on both the public internet as well as that VPC network. So it's 2 NICs, so it's able to kind of broker that connection and bring me through the worker onto that machine. So I should be able to do a Boundary connect. And one thing I want to quickly show is the idea of sessions. So one of Boundary's big benefits as well is the ability to look at sessions and kind of it logs every single session that happens. So you can see I was doing some testing yesterday where the idea is that every time I connect, a session is going to show up here. So let's test it and do Boundary connect. And I'm going to say yes. And boom, I'm now in my GCP instance, which is the Ubuntu host. And I've now, you can see a session has now showed up. It is the user that's running it as, the target, as well as the status that it's active and when it started. So it's pretty cool, right? I'm now in my GCP instance, right? You can see my private IP address there. So obviously I'm not on this 10.142 network. So we've essentially kind of bridged that. So now that all of my machines don't actually need like a public IP for me to get to them. And the other big benefit here is 2 things. I can just do an exit myself, which will then stop this connection and it'll say now terminated. The other thing I can do is do a connect again. That should show up. And then on the Boundary side, I can just do a cancel if I don't believe that that person should have connectivity anymore. I can cancel it and I'm kicked out of the session.
That's very cool.
Yeah, so that was like a quick 10-minute version of it. I think I covered everything I wanted to. Yeah, so that's pretty much it for Boundary. Yeah, it's a pretty cool tool. I know they want to bring in a lot of new features like pretty quickly as well. The other one is how did I connect to this machine? And really the answer is I have my SSH key sitting on here. So it doesn't really technically scale right now because then I'd have to have every single user's SSH key or give them a static password. So the idea there is to leverage, I think Boundary to leverage Vault because Vault already has a secrets engine that can dynamically generate SSH passwords. So Boundary can utilize that. So I can get like a one-time password or a password that's short-lived and then let Vault handle the revocation of that. And then have Boundary kind of at the session level to say, okay, you're kicked out.
Yeah, I like the idea of being able to essentially go in and kick people out. That's pretty powerful, pretty tough to do without something like this.
Yeah, absolutely.
All right. Well, thanks for the demo there for something that's extremely new. I'm going to kill the screen here. We can handle a little bit of Q&A. We did have a couple of questions. We have one here, just around a quick rundown of what makes Boundary different in terms of remote access, and how is that different from a traditional VPN?
Yeah, so I think like my take on it, and I could be off, but the whole idea with it, I think, is that onboarding process, right? So the way I traditionally think about it is, if I need to get onboarded onto like even as us as consultants getting onboarded onto like a customer environment, best case we get like an RDP machine. A lot of times, like we're actually getting like physical laptops where that's going to have like a VPN client installed on it. And there was some work that was put into that VPN client, right? Like I said, there's that whole process of essentially creating it, and whatever that process looks like on the customer side. The other side of it too is there was probably a lot of firewall rules that were put in place where obviously they're not going to give me keys to completely everything in the organization. We were brought in here to do the job of work in like the development side, or work on their Vault servers or Consul servers or Terraform servers, whatever the case may be. So I've set up firewall rules that say Jacob's only allowed to access those servers and nothing else, and only in dev, right? So there's a lot of work that's put behind it. And I think what Boundary's trying to solve there is, well, let's kind of do this at a more quick and dynamic way, where I'm now using based off tags or something even like Consul eventually, where I'm using Consul as a service discovery tool to kind of dynamically generate this host catalog. Oh, you can't see my screen anymore, but dynamically generate that host catalog that says, okay, Jacob has access to this server, this server, this server, because that's what's provisioned right now. And once I deprovision a server, that will automatically get removed from the host catalog. Where if I delete a server right now for someone's using a traditional firewall, that firewall rule is still in place unless I actually went and deleted it. So I think that's where kind of the power comes in. I think it helps a lot just because HashiCorp has a really strong stance on like Vault and Consul. So I think once they can bridge these applications together and have Boundary kind of sit in front, I think it'd be pretty powerful tool.
Cool. Yeah, no, that makes sense. And then just one last one, and I'm kind of assuming the answer is yes to this question, but is it like other HashiCorp tools where the binary is the same between the server and client? So it's a single binary for everything, or? Yeah,
it's a single binary everything. It's like, I think the difference is like Boundary server, and then I don't, you'd actually have to specify what you do is you just point it at the HCL file. And then that dictates whether it's a controller or a worker, I think.
Gotcha. So similar to Vault.
Similar to Vault Consul, which was awesome, like I said, because when I was trying to learn this and spin it up, the painful part wasn't spinning it up, because I just basically cloned my Consul Ansible role and literally just the Command F Boundary. I had to change like some other stuff, but that's how it was pretty straightforward.
Very cool. Awesome. Well, that I think pretty much wraps it up. I don't see any other questions to answer live here. So, of course, we're always available. I kind of said like and subscribe and all that good stuff, and, follow us on Twitter. Happy to answer more questions and get engaged to help, understand the new tools like what Jacob's showing, or, some of the other stuff we demoed today. It was a really fun event. So thanks for kicking in and doing some awesome demos, guys.
Yeah, thanks. Thanks everyone for joining.
Any last words from anyone just around the text they demoed or anything like that?
What mountain are you skiing on?
Yeah, I'm looking forward to hitting the slopes. It seems summer's done, so I'm gonna join my friends back here, get some time up in the mountain.
Nice.
Awesome. Cool. Thanks, guys. Thanks everyone for joining, and we'll see you at the next event. Until next time.
Thanks everyone. Take care.
Bye.
Bye.